Did you know that there are certain unit conversions that are not covered on the reference manual, but you need to know them for the FE exam? Well, they are. Plus, there are some units that if you memorize them, it will help you solve problems faster on the exam. Now, if you guys want to know what these units are, then keep watching. Oh yeah, everybody now. Bonjour guys, welcome back to my channel. For those of you guys who don't know me already, my name is Kenza and I've helped hundreds of students pass the FE exam. So in this video, what I'm going to do is share with you guys some of the units and unit conversions, but also I'm going to explain some of the units because sometimes when we understand something, we tend to remember it, we know when to apply it and also how to apply it. Now, before we get started, I want you guys to make sure that you grab the cheat sheet and just print it out, or you can export it to your computer or your iPad so that you can take notes along with me. So it's important that you guys engage with the material and you take notes and engage with the examples that I'm going to share with you guys here, so that way you remember all these concepts for your FE exam. Now, to grab the cheat sheet, all you need to do is sign up in the link in the description below and you should get it in your email right away. So the units that we're going to cover here are mostly going to be for statics. However, keep in mind that these units will show up in other sections as well, like mechanics of materials, dynamics, fluid mechanics, and so on. But if you guys are interested in seeing a video like this, unit cheat sheets, but just for dynamics, comment dynamics below and I'll make a video on that. So the first thing we're going to do here is just review some of the units and then we're going to do the unit conversions. Now note guys here how we have SI and US units, and that's because on the FE exam you will get both. So make sure that you guys know the SI units and US units for your FE exam. Now let's go over the units for acceleration. So acceleration has a unit of length per time squared. If we are using SI units, that would be meters per second squared. And if we are using US, that would be feet per second squared. Now another thing you guys should remember is the acceleration of gravity, which has a value of 9.81 meters per second squared if we are using SI, and 32.2 feet per second squared if we are using US units. Now what you guys need to do is add these values to the second page of your cheat sheet, and you should also remember these values for your FE exam. Although if you do a lot of problems for the FE, you will just automatically remember it. But if, let's say, on the FE exam somehow you just forgot about those values, well, don't worry, because they are provided to you and their units on the first page of units, and these are the values here. Now let's go over mass. So mass has a unit of kilograms if we're dealing with SI units, and pound mass if we're dealing with US units. Now, a lot of times when we are solving problems, we don't really include the M. I myself don't do it, and now that I think of it, I feel like it's important to actually include it because we don't want to confuse it with pound force, which is the unit of force. So if you have mass, when you are writing the units down, try to write pound mass and for mass so that way you can differentiate it from force. Now let's go over the units for force or point load. So if we're dealing with SI units, that would be Newton. And if we're dealing with US units, that would be pound force. Now let's go over the Newton a little bit. So Newton is technically kilograms, meters per second squared. So let's go over this a little bit more. So what is force? Force is equal to ma, right? Newton's second law. Now what is the unit of mass? That's kilograms, right? We mentioned it here. The unit of acceleration is meters per second squared. This here gives us the unit of Newton. So it's important that you guys understand these concepts because this will help you feel confident and also pass your FE exam. Now let's go over the pound force. So what I'm about to share with you guys is really important. And when I first learned about this back in college, I remember that I was very confused for a while. And I feel like not a lot of people know about this, and it's important that you guys not only know about it, but also apply it when you are solving problems that involves force, mass, weight, all of that. And I'm going to dive in more into that in a little bit. So what we're going to do here is we're going to apply the same steps as we did with here, okay, with Newton. So we're going to have force is equal to mass. Now mass in US units, it's pound mass, and an acceleration is feet per second squared. Now, this is where it gets tricky pound mass feet per second squared is not equal to pound force. So when we try to go from pound mass feet per second squared to pound force, what we need to do is use the constant GC. Now GC is equal to 32.2 pound mass feet, and then we divide it by pound force seconds squared. Now let's plug in this in the equation, and you guys will see how the units will cancel and how we are going to have pound force as a unit, which is the unit of force. So force is equal to MA, and then what we do is we actually divide by GC. So now what we're going to have is pound mass and then feet per second squared, and then we're going to divide it by 32.2 pound mass and then feet, and we're going to divide by pound force, and then we have seconds squared. So let's go over the units. So note guys, here the pound mass cancels, and then here we had feet per second squared also cancels, and we're going to be left with per pound force, which is the same as pound force, and pound force is the unit of force. Now you're probably wondering, when do we use GC, right? Well, we actually use it when we dealing with force. So when we have force is equal to MA, we always divide by GC if we are working with US units. Another time we use GC is, I'm going to show you guys here on the reference handbook. So you are giving all of this in here, so you can take a moment and just read about it more here. Also, we use it when we have kinetic energy, potential energy. If you guys are interested in the unit cheat sheet for dynamics, I'll probably talk about this and dive in more into it. Also fluid mechanics, specific weight, and so on. And another one is weight and mass. So when we convert from weight to mass or vice versa, we also use GC, which I'm going to talk about in a little bit in this video. Now let's take a look at weight. So weight has actually the units of force. So for SI, that would be Newton, and for US, that would be pound force. Now note guys how weight and mass are pretty close. So that's why it's very important that you guys differentiate between the two. So mass has the units of pound mass, and then weight has the units of pound force. Now we have distributed load, which is common when we have a beam, and it has the units of force per length. When we're dealing with SI units, it would be newtons per meter or kilonewtons per meter. Now, I am going to show you guys in a little bit how you go from newtons to kilonewtons, vice versa, because it's important for the FE. And then for US units, it would be pound force per foot. Or it could also be Kips per foot. Okay? Now, we also have moment, which is force times distance. Now, when we're dealing with SI units, that would be newtons meter or kilonewtons meter, and for US units it's going to be pound force foot or Kips inch. Now Kips inch, it's not very common. You will see it in concrete or when you're doing concrete problems, but not necessarily in statics or mechanics of materials. Now another thing I like to do here is show you guys why it's important to know these units, and what we're going to do is an example that has point load, distributed load, and a moment. Now this example, you already have it and it is on page 3. So let's take a look at it together. So we have a simply supported beam that is subjected to a point load, a distributed load, and a moment, and we want to find the reaction at B. So the first thing we're going to do here is take the moment at A and just equal it to 0. Now we're going to assume the counterclockwise to be positive. And so if we do that, let's first take a look at the point load. So we're going to have minus the point load. Point load has a unit of Newton, right? Now note guys here that this is a moment equation, meaning that every single term in the equation should have a unit of force times length, right? Or newtons times meters. So here what we need to do is multiply P, which is the point load, which is the force, by the distance. Now, it was mentioned in the problem that this point load is applied at mid-span, so that distance is going to be L over 2, and it's going to have the units of meters. And then we're going to have minus the distributed load, newtons per meter, that's the unit of the distributed load. Now what we need to do here is take the distributed load and multiply it by 2 lengths. Now these lengths are not going to be the same, they're not going to be equal, but we have to do 2 lengths so that one length cancels with this meter, and then we're going to be left with Newton's meter, which is the units of moment. So the first length is going to be the length of the whole beam, the span of the beam, and it's going to have the units of meters. And then we're going to multiply it by L over 2, because we're going to assume that this distributed load is applied at mid-span, and this also going to have the units of meter. Note guys, here this meter cancels with this, and then we're going to be left with Newton's meter, which is what we want. Now let's take a look at the moment. So what we're going to do here is plus moment and then Newton's meter. Now here's something that I see a lot of students do, is that they take the moment and then they multiply by the distance. And you should not do that, because this is the moment equation. This is already a moment. So all you need to do is just add it or subtract it. In this case, we had to add it, but it already has the unit of moment, Newton's meter. So you don't need to multiply it by distance or anything. So keep that in mind. Another thing to remember is that when you are working with the force equations, right, instead of the summation of the moment, instead you have the summation of forces. And if you have a moment, don't include the moment in your force equation. Every term in the force equation should just be forces, Newton, right? No moment. So keep that in mind. Now, if you guys want to see examples on this with numbers, just let me know in the comments below. Just comment beams with loads and I will make a video on that. Now, the last thing we're going to add here is the reaction at B. That's what we're trying to solve for. And so what we're going to do here is plus By. Now, the units of By is going to be Newton, because it's a force, right? It's a reaction. And then what we need to do here is multiply it by distance. So that way we have moment. Now, the distance is going to be L, because we're taking the moment at A. The distance from A to B, it's L. So this is going to be L meters. And this whole equation is going to be equal to 0. Now, note guys here that when you're going to try to solve for By, so let me just quickly do it here. So you're going to have Newton. And then here, all these terms, they have the units of Newton meter, right? And then this L, what we're going to do is divide by that L. I'm just going to write L here, meters. So it's going to be all these terms divided by L, meters. And note guys how the meters and meter cancel, and you're going to be left with newtons, which is the unit of the reaction. So when you are solving problems and when you're studying for the FE, or maybe even the day of your FE, if you write the units down, if you miss something, you'll be able to see it because your units won't cancel. So that's why it's important to keep in mind the units and make sure that they cancel, and make sure that at the end you have the right units. Now let's go back to our table. So we have friction. So remember guys, friction is the force that is parallel to the surface but opposing motion. So it's going to have the units of force. So for SI, that's going to be Newton. For US, that's going to be pound force. Next we have is coefficient of friction, which doesn't really have units, so it's dimensionless, whether we're working with SI or US units. Now we have centroid, which has the unit of length. If we're dealing with SI units, that would be meters or centimeters or millimeters. Another thing that it's important that you guys know is how to convert from meters to centimeters or vice versa, or meters to millimeters, which is something that I'm going to cover in a little bit. If we're dealing with US units, centroid usually is in inches or feet. Now, moment of inertia is in length to the power 4. So if we have SI, that's going to be meters to the power 4, or centimeters to the power 4, or millimeters to the power 4. If we are dealing with US units, it's going to be inches to the power 4 or feet to the power 4. Now, before we continue, if you guys are enjoying this video, don't forget to like and subscribe to get more videos like this to help you pass your FE exam. Now let's go over some unit conversion. You guys already have this, it is on page 4. So the first thing we have is Newton to kilonewton. Sometimes we might have a large number, let's say 17,000 Newton, and what we like to do is convert it to kilonewton, so that way we have less zeros and it's just easier to work with. So to go from newtons to kilonewtons, what we usually do is we divide by 1,000. So if we take Newton divided by 1,000, we get kilonewton. And same thing with pounds to kips. So if we want to go from pounds to kips, we take the pounds, we divide it by 1,000, that usually gives us kips. Now, let's say we want to go the other way, let's say kilonewtons to newtons, in that case, what we do is we multiply by 1,000. So if let's say I have 7 kilonewtons, if I want to go to newtons, I would just multiply by 1,000, and that's going to give me 7,000 newtons. And same thing with Kips. If we're going from Kips to pounds, all we need to do is just multiply by 1,000, and that usually gives us pounds. Now let's take a look at meters to centimeters. If we want to go from meters to centimeters, what we usually do is we take meters and we just multiply it by 100, and that usually gives us centimeters. And the same thing with millimeters. So we take meters, we multiply it by 1,000, and that usually gives us millimeters. Now also, it really helps to think of it this way. So let's say we have 1 meter, we can say 1 meter equals to 100 centimeters. And then we can do the same thing with millimeters. 1 meter is equal to 1,000 millimeters. So this becomes helpful, especially when we're trying to convert from millimeters to the power 4 to meters to the power 4, or meters squared to centimeters squared, and so on. Now, if we want to go from centimeters to meters, we just divide. So we would divide centimeters by 100, that would give us meters, and then the same thing for millimeters. So we would take millimeters divided by 1,000, and that would usually give us meter. I also want to share with you guys this diagram, which you can find under page 5 in your cheat sheet package. And I've actually learned about this diagram when I was in elementary school. I went to a bilingual school where we only dealt with matrix systems and SI units. And since I learned this diagram, I never really forgot how to convert from meters to centimeters and so on. And that's why I wanted to share it with you guys. So hopefully after this, you never forget how to convert either. So what we have here is kilometers. This is hectometer. This is decameter. Then we have meter, then we have decimeter, centimeter, and millimeter. Now, this unit here and this unit, you don't need to know. It's not common on the FE exam or engineering problems. All you need to know is kilometers, meters, centimeters, and millimeters. But I'm including them in this diagram because it actually helps us to remember the conversion for centimeters, millimeters, and kilometers. So usually if we want to convert from meters to decimeter, we usually just multiply by 10. If we want to go from meters to centimeters, we multiply by 100. And then from meters to millimeters, we multiply by 1,000. Note guys here how there's a pattern, right? So first we have 10, then we have 100, then we have 1,000. So that's why it kind of helps to include decimeter, even though you don't really need to know it. Now, if you want to go the other way, let's say millimeters to meters, or centimeters to meters, you just need to divide instead of multiplying. Now to go from meters to decameter, here instead of multiplying, we actually do the opposite, we divide. So from meter to decameter, we're going to divide by 10. From meters to hectometer, we're going to divide by 100. And then from meters to kilometers, we're going to divide by 1,000, okay? Now, if we want to go from here to here, then instead of dividing, we multiply. So from kilometers to meters, we would actually have to multiply by 1,000. Another reason I really like this diagram, it's because we can apply it to other units as well. So if we want to go from kilograms to grams, what would we do is just multiply by 1,000. And if we go from grams to kilograms, we would divide by 1,000, just like we did here with meters to kilometers. And then same thing for kilonewtons and newtons. If we go from kilonewtons to newtons, we're going to multiply by 1,000. And then if we go from newtons to kilonewtons, we divide by 1,000, just like we covered before. Same thing with Kips and pounds, and then kilopascal and pascal. Now for kilopascal and pascal, when you are doing problems under mechanics of materials, you're going to also see megapascal and gigapascal and so on. And it's important to also know how to convert those. Now, if I do create a unit cheat sheet for mechanics of materials in the future, I will probably cover that as well and share with you guys. Now, let's go back to page 4 and finish this up. So if we have, let's say, feet to inches, what we're going to do here is take 1 foot, we're going to multiply it by 12, and that would give us inches. Another way to think of it is that 1 foot is equal to 12 inches. Now, if you are used to US units, you probably already know this conversion. But if you are used to matrix systems or SI units like I used to, you probably don't know this. And I recommend that you guys remember this because it's very common in engineering where we'd have to convert from feet to inches and vice versa. And I don't think this conversion here is on the reference manual. I couldn't find it. If you guys found it, please share that with us in the comments below. The next thing we have is inch to feet. So if we want to go from inch to feet, all we need to do is divide by 12. Now let's take a look at how to convert millimeters to the power 4 to meters to the power 4. And to do this conversion, what I'm going to do is walk you guys through an example. Now this example, you have it under page 6. So here what we're going to do is find the moment of inertia in meters to the power 4 about the centroid or x-axis. And note guys here how the dimensions were given to us in terms of meters or millimeters. So what we're going to need to do is find the moment of inertia, and it's going to be in millimeters to the power 4, and then we're going to have to convert millimeters to the power 4 to meters to the power 4. So let's go to the reference manual and grab the equation for the moment of inertia for the rectangle above the centroid or x-axis. Now, if you guys already watched the video where I talked about how to quickly find the equations on the reference handbook, you probably know by now to get the equation for the moment of inertia, what we're going to do is click dynamics, and then we're going to scroll up because we know that the tables, they are under statics or at the end of statics. Now, if you haven't watched these videos yet, I recommend that you do because these are going to really help you find the equations faster and use the reference handbook effectively, which will help you pass your FE exam. Now, if you guys plug in these numbers, this is what you're going to get. Also note guys here how we have millimeters and then millimeters to the power of 3, which gives us millimeters to the power 4, which is the units for moment of inertia. Now, if we want to go from millimeters to the power 4 to meters to the power 4, this is how I usually like to do it. So I like to actually write the units down. So here we want meters to the power 4. So that's going to go to the top. And what we need to do is cancel the millimeters to the power 4, which means millimeters to the power 4 is going to go to the bottom. So now this will cancel with this, and we're going to be left with meters to the power 4, which is exactly what we're looking for. And then also, if you guys remember earlier, I mentioned that 1 meter is equal to 1,000 millimeters, right? And I said it's helpful to think of it this way, especially when it comes to these kind of problems. And that's what I'm going to do here. So we have 1 meters is equal to 1,000 millimeters. But the thing that you got to be careful with here is that we're not just converting meters to millimeters, but we are also converting millimeters to the power 4 to meters to the power 4. So which means we have to make sure that we raise this 1,000 to the power 4. Okay, so that's the only thing that you guys got to keep in mind here. And then that's it. Once you do that, you just plug in. Now, another thing we could have done is just converted the 12 millimeters to meters, and then we could have done the same thing with the height. The only problem is here we could have done that and it could have been faster. But sometimes when we have long problems and when we have, like, let's say we have to use the parallel axis theorem and then we have a rectangle and then a circle inside the rectangle, when it becomes so many terms and so many variables, it's faster to actually just leave all the units as they are and then just convert till the end. And also, it's important that you guys know how to convert from millimeters to the power 4 to meters to the power 4. Now let's do this example here. So what I recommend that you guys do is maybe pause the video and give it a try. It's going to be the same steps here, except we're going to need to convert inch to the power 4 to feet to the power 4 and then see if you get the same answer. So here, if we actually apply the equation, we're going to get the same number. It's not going to change. The only thing that's going to change is the units. Here, we're going to have inch to the power 4. And what we're going to do here is now convert inch to the power 4 to feet to the power 4. So remember, we want the feet to the power 4 at the top, and we want to get rid of the inch to the power 4. And now we're going to ask ourselves how many feet we have in inches. And if you guys remember, we said earlier 1 foot is equal to 12 inches, right? So 1 foot is going to go here, 12 inches is going to go here, but don't forget to raise this term to the power 4, because again, we're converting inch to the power 4 to feet to the power 4. The steps that I just shared with you guys are exactly how I convert units. And see, when I first learned about units conversion, which was in college, my first chemistry class, I really struggled through it. I don't know why, but I just had a hard time understanding it. And then my professor walked me through it and he shared with me steps. And then since then, it has been so easy for me to convert units. Now, so far, we have been doing really simple, straightforward unit conversions. But if you guys want to see like video of more examples of unit conversions, or like how to convert more complex units like gallons per minute to cubic feet per second, or meters to inches, or just more examples, just let me know in the comments below. You can just comment steps and maybe I'll make a video on that. Now, the last thing we're going to cover here is mass and weight. And let's first go over mass to weight. So this is actually common when we have problems like this. And so let's say here we were giving the mass of block D in kilograms. Let's first start with SI units. And when we set up the summation of the forces on the y equals to 0 equation, if you guys remember, I mentioned this before, every single term in this equation has to have the units of force, right? Which is newtons. Now, mass doesn't have force of newtons, right? So what we're going to need to do is take the mass and convert it to weight. Now, to do that, all we need to do is just take m and multiply it by g, right? Because if you guys remember, the units of newton is what? Kilograms, meters per second squared. We have kilograms, that's the mass. We just need meters per second squared, and that's going to be gravity, which is 9.81 meters per second squared. So when we like to convert, to get the weight or convert mass to weight, what we usually do is the weight is equal to m times g. M is the mass and g is 9.81 meters per second squared. Now let's take a look at US. So when we're dealing with US, you guys gotta be careful because there is GC, right? So earlier when we did force is equal to MA, when we're dealing with US, we always have to divide by GC, right? And GC is the constant, which is 32.2 pound mass feet per pound force second squared. So here, when we're trying to convert mass to weight, we actually do mg and we have to divide it by gc. So whenever we convert from mass to weight or weight to mass, we always have to use gc. So keep that in mind, guys. Now, another thing is, what I want to do here is plug in the numbers or the units. So here we're going to have weight is equal to mass. So mass is going to have the units of pound mass. Now g is 32.2 feet per second squared, right? So for SI, we said it's 9.81, but for US, it's 32.2. And then we're going to divide it by GC, which is going to be 32.2, and we're going to have pound mass, foot, and then we're going to divide it by pound force, and then second squared. Let's take a look at the units. So pound mass is going to cancel, feet per second squared cancels, and then we're going to be left with per, which is the same as pound force. And also note, guys, here how the 32.2 cancels with this 32.2, which means that in this case, the weight is going to be the same as the mass. They're going to be the same number. And this is actually true, but only true when we're on Earth, when gravity is equal to 32.2. When gravity is not equal to 32.2, G and GC, they don't cancel, and the weight is not equal to the mass. So keep that in mind, guys. Now, if you guys want to see a video where I solve this example here using US units, just comment below example on forces and I'll make a video on that. Now, let's go over weight to mass. So to do this, we're just going to do the opposite of what we did here. So M is just going to be equal to W over G. And then for US, it's going to be M is equal to W times GC. And then we're going to divide it by G. Now, to go from weight to mass, this is actually more common under dynamics. So when we are dealing with momentum problems, sometimes we are giving the weight and we have to use the mass, so we'll have to convert. But I will cover that on another video, but just keep it in mind for now. Now, let's talk about options for future videos. I did mention a lot of ideas here, so let's recap. The first video we have is units for dynamics. If interested, comment dynamics below. We have an example of simply supported beam with all different loads. Comment beam with loads below. We also have steps on how to convert more complex units. Comment steps below. And lastly, we have an example with forces. Comment example on forces below. If you want all of these videos, go ahead and comment all below, and the video that gets most comments will win. Now, if you guys enjoyed this video and you feel like you grasp a lot of concepts, then you'll love our courses where we solve a lot of problems and I share a lot of concepts that will help you pass your FE exam. I also want to congratulate 6 of our students who passed the FE exam in October. I am really proud of them. They really put in the work, they studied the right material, and it's all paid off. So congratulations to all of you guys. Now, while you guys wait for the next video, make sure that you guys check out these 2 videos right here, which will help you with your FE preparation. And thank you guys for watching. I hope you have a great week and I will see you on the next video. À la prochaine. Oh yeah, everybody now.